So here we're going to just use what we learned about all of these different quadrilaterals and their properties to answer these true and false questions. And then on the next few slides, we're going to use the properties to find missing values and lengths and measurements, basically combining algebra and these properties that we just learned about. So these are each true or false questions. I'm just going to write true or false based on either the naming convention used in the Venn diagram or thinking about specifically the properties of what we're talking about and seeing if all squares really do satisfy the condition of being a parallelogram, which they do. They have two pairs of opposite sides that are parallel, which is the only condition of a parallelogram. Every square satisfies that, so that's true. Another way to think about that, in this Venn diagram, you can see that all of our squares are contained in this circle of parallelograms. All of these squares, any kind of square, is going to be contained in that family of parallelograms. So that is true. All squares are parallelograms. All rectangles are squares. That is not true. There's some that are out here in this Venn diagram that are not going to be called squares. They would just be rectangles because they do not have every property required of a square, which is 4 congruent sides also. So that one's false. All rectangles have bisecting diagonals. Well, right away, parallelograms have bisecting diagonals, and all rectangles, every single rectangle is contained inside that group of parallelograms, so that is true. If it's a trait of a parallelogram, then it's inherited down into these smaller groups inside of the parallelogram, into these subsets of that bigger set of shapes. All rhombi have two pairs of congruent angles. Again, that's a property straight from a parallelogram. Opposite angles are congruent, so the rhombi also carry that property. That one's true again. Base angles of a trapezoid are congruent. If it said an isosceles trapezoid, then that's true. But base angles of a normal trapezoid do not have to be congruent, so that is false. Consecutive angles in kites are supplementary. So that is true of all parallelograms, that these consecutive angles, the ones that are next to each other, those are going to be supplementary. But that's not necessarily true of a kite. We don't actually have the parallel lines and the transversal that we would create with a parallelogram with each of these. The kite doesn't form that. These two are not necessarily supplementary, so that's going to be false. All right, so now we're going to use what we know to solve for a missing length or variable or a measurement of an angle. So here we're told that PQRS is a rhombus, which means all of these sides are congruent, which is really the piece of information that I needed. I'm going to solve for the length of QR, this length, which is the same as actually all the other three sides. So I'm going to solve for Y, and then plug it into either of these, they should be the same, to solve for the length of QR. I know that these lengths are the same, so I'm going to set them equal to each other. 2y plus 3 equals 5y minus 6. So we'd get 3y by subtracting 2y on both sides. And then I'm going to add 6 over to the other side and get 9 as my constant, and then divide away the 3. And that tells me that y equals 3. That's just the value of y. I want to find the measure of these lengths. So I'm going to plug it into this one. That would give me 6 plus 3. I could plug it into that one too. That would give me 15 minus 6. I'm just really confirming that that does give me the same length, which is 9. ABCD is a parallelogram. So this and this is parallel, and this is parallel to this. We also know that these sides are congruent, these opposite sides. This one is congruent to this one. This, we don't really know the relationship between this side and these two, so I'm not really going to mark that with anything. I just know that these are congruent, so that's going to help me find the value of x. I really want to find the length of BC, which is going to be the same as this. I have no way of finding the x from that expression, but these two are equal to each other. So that gives me 3x plus 5 equals 6x minus 10. That would give me 15 equals 3x, and then I would divide by 3 to find out that x is 5. So the value of x is 5. I'm going to take that and plug it back in here to find the length of these two sides. That would be 20 minus 5, or 15. All right, SR and PQ are parallel. SR and PQ are parallel. and RQ and SP are parallel. So we have a parallelogram. We have two pairs of parallel sides, which tells me a lot actually that these are congruent. These are congruent. Also tells me that the diagonals are being bisected. So 1, 2, 3, these parts are congruent. This is split directly in half. That's the midpoint of SQ. It's also the midpoint of PR, which means that these are congruent. 20 equals 7 plus y. Really, that's how we're going to find our first variable. We can't really use this one. 16 equals x plus y. We don't know either of those, but this is going to help us find y. It's going to tell us that y is 13. And now we can take that value and plug it back in there to find that x is just 3. Oops, I meant to plug it in. So here we see the length of each diagonal is 36. So the length of that diagonal is 36 and that diagonal is 36. If this is a quadrilateral and I have congruent diagonals, that means this has to be a rectangle. So if this is a rectangle, that means these diagonals also bisect each other, which means that these are congruent. That's the midpoint of this line. So these two pieces are congruent to each other, which means that if this entire thing is 36, just this part would have to be 18. This part would have to be 18 also. So 2x plus 4y equals 18, and then 4x minus just y equals 18. So now I have a system of equations that I can solve. I'm going to multiply this bottom equation by 4 so that my y's will cancel out. Multiply that times 4, multiply this times 4, and multiply this times 4 to use elimination and cancel these out. I'm going to add these two equations together and get 18x equals, my y's completely drop out, and that equals 90. And then I divide by 18 to give me the value of x. It's just 5. All right, on number 5, we see that DEFG is a parallelogram. So really looking at the angles there, I know that these two consecutive angles, if this is a parallelogram, these two are going to be supplementary. These two would be congruent, they're opposite. These two would be congruent, but the two that are next to each other here, or here, or here, or here, are all supplementary. So they're going to add up to 180. So that is our equation. This one plus this one equals 180 degrees. That would give us 7x plus 12 equals 180. And then we'll subtract 12 from both sides and get that 7x equals 168, and then divide by 7 and get that x is 24. I might double check to make sure that this actually makes sense in here. Plug this in, you get 48 plus 12, that's 60. Plug this in here, you get 120. Just double check to make sure that we actually did everything correctly, and those are actually supplementary there. And on the last one, which should definitely be number 6 here, PQRS is a square, so that's a square, which means all of these are congruent. And actually, this is a 45-degree angle. We also know that these are congruent. Not to that, so let me mark that with 2. Actually, I don't really need the internal segments there. I just am going to use these two equal to each other. So that's going to be my first equation, 4x plus 3. Can't really do anything with this yet. I can set up that equation, 3x plus 6y equals 45. But with those two variables, I can't really solve that yet. However, I can solve this one to find one of those variables. So 4x plus 3 is congruent to or equal to 31 there. That tells us that we're going to subtract 3 and divide by 4, and tells us that x is 7. Now we can take that value and plug it in there. And now we just have one variable in that equation. So we get 21 plus 6y equals 45. We would subtract the 21 from both sides and find that y is 4.